GameSci.com. GameSci.com. Welcome to GameSci.com. I am Professor Chris Ferguson.
Variables. Variables are very important to video games. Variables are where we store all the information about our player, our character, our score, our health. Variables, according to dictionary.com, a variable is likely to change or vary, subject to variation, changeable. My definition, I've always thought of a variable as a location in computer memory where I can store something. A little cubbyhole where I can put a piece of information to use later in my computer program. Understanding variables is the key to understanding computer programming, and it's a key to understanding object-oriented computer programming. If you're going to be a game programmer, you're going to have to learn about variables and how we store information in them. Let's start with the simplest of variables, an integer, or int. We're going to store the X position of our character. In a two-dimensional video game, the character is going to move along an X and Y axis, and we need to keep track of the X position of our character. Now, I've made a simple declaration here with no initial value. So you can see as I've allocated the space for the variable, but the two question marks indicate that I haven't stored a value in there. I shouldn't use this variable until I store a value in it. The counterpart to the X position is the Y position. Again, in a two-dimensional game, you need to keep track of the X and Y coordinate of the character. So I'm declaring int Y position, and this time I'm going to assign it an initial value of 50. So not only will it allocate space in computer memory, but it will store the value 50 in there. Now, it's called a variable because this can change. As the character moves, we plan to change this value. An integer is a whole number without a decimal point. You can see there is no decimal point in this number. An integer is a number without a decimal point. Next up, let's declare a double variable named money and assign it an initial value of $20 and no cents, or 20.0. Again, we will allocate the space for the variable in RAM memory and initialize it with the initial value of 20.0. This player is going to start the game with $20 and no cents in the bank, and they will go up and down from there as they acquire or lose money. Double is short for double precision floating point. That keyword double tells you this number will have a decimal point. It takes more memory, so when we declare it to be a double, it will allocate more space to hold the value for money than it did for X or Y position. The next variable up is char, short for character. We're going to declare a char rank and assign it the initial value A. I assume A will be a highly ranked player, B would be lower, C would be even lower than that. We're going to rank the player as they gain strength and acquire power. They'll go higher in the rankings. As they lose strength and lose health points, they'll go lower in the ranking. So we'll use a single letter to rank the player. Everybody knows the A, B, C, D, E, F scale. Let's use a single letter to keep track of the rank of the player. Finally, let's create a Boolean variable named paid user. We'll assign it the initial value true. A Boolean variable can only hold two values, true or false. You can see here I've decided to initialize my variable with true, and it will allocate the space and assign the initial value true to it. I kind of showed this a little bigger than it needs to be, but I wanted to fit the word true in it. So a Boolean variable takes very, very little memory to store. Java is a strongly typed computer language. As a strongly typed computer language, we are required to declare our variables before we use them. And what we're doing here is declaring the variables X position, Y position, money, rank, and paid user. Java requires this so it knows how much space to allocate for the variable. For instance, ints in Java take 4 bytes of memory, a double takes 8 bytes, a char takes 2 bytes. Most languages are similar or slightly different sizes. A boolean technically only takes one bit of computer memory, but probably takes a byte. Anyway, we need to declare these variables before we can use them. That's what a strongly typed computer language insists on. You must declare your variables before you start using them. Let's move on and look at a little more details on variables. The key to understanding variables is to understand they have a name, type, and value. Variables have a name, hopefully a descriptive name, which is good. Short abbreviated names are bad. So you can see I've got variables on this screen like score and health. They're keeping track of the player's total score and their health value. We hope the score value goes up, and we hope that the health value does not go down too far. A good name is extremely important. If you start naming variables like score with abbreviations like S or SC and health is H, it's very difficult when you're looking at the code to tell what's being stored in the variable S or stored in the variable H. However, a good name like score is immediately obvious and recognizable. And anytime you see it used in the code, you understand what's being stored in that variable. Same for health. Is there any doubt what that means? Is there any doubt that health of 100 is a good value in the health variable and a health of a 0 is a bad value in the health variable? Not only will you be able to recognize and understand what's being stored in the variable, you'll also be able to recognize and understand good values and bad values. No one expects a score of minus 60, and no one expects a health value of a negative number. Variables also have a type. What are you storing? Are you storing a whole number, an integer? Are you storing a decimal or floating point number? Are you storing letter or letters, or a true-false value? You must name the type of variable when you're declaring it. Variables also have a value. What is the current contents of the space allocated? Every variable gets a little piece of RAM memory, a little piece of computer memory, and what number or what value are we storing in that variable space? Again, let's do some examples. Score, this will be the player score of our video game. We expect that score to go up as the player advances in the game. We'll always initialize that to 0. You should start with a score of 0. It'll allocate the memory to hold it and put the value 0 in it. We'll allocate a variable health, set it equal to 100. In this case, int is the type of the variable, health is the name of the variable, and 100 is its initial value. Name, type, and value of the variable. One of the reasons I'm declaring the variables this way is you can see all three pieces: the name, the type, and the value of the variable. A double, as we've said before, is a floating point number. It's a number with a decimal point. What is the strength of this player? I assume there's some element in the game where if you acquire strength, you'll go up. If you take damage, your strength should go down. We'll put that as a floating point number. It could be an integer, but we want a decimal point. We want to be able to shrink and do it by fractional parts. If you need a fractional part, you need a decimal point. We're going to declare this variable to be a double. So you can see the type of this variable is double. We expect it to have a decimal point. The name of this variable is strength, the strength of the player as the game progresses. High strength is good. Low strength, of course, is bad. And then the initial value, 4.67. Don't ask me why. I just wanted a number with a decimal point. Let's declare a character called suit. If we were playing a card game of some sort, the suits of the playing cards would be H for hearts, D for diamonds, C for clubs, S for spades. So if we had some sort of playing card part of this game, in order to store or shorten the amount of memory needed to store that information, we'll just use a single letter H for hearts. Again, you can see we're allocating the space and initializing it with the value H. The type of this variable is character, or char. The name of this variable is suit. What is the suit of the playing card shown on the screen? And of course, the value is h, h being short for hearts. When you think about variables, you're going to have to focus on three things: the name of the variable, the type of the variable, and the value of the variable. In the case of int score equals 0, the name, of course, is score. How many points has the player acquired? The type is int. We decided that will be an integer value, a number without a decimal point, and the value, at least the initial value, is 0. Of course, we hope that value goes up as the game goes on. There you have it. Name, type, and value. Those are the critical components. Every time you look at a variable in your computer program, ask yourself, what is the name, type, and value of this variable? Once you've declared a variable, it's time to start changing those variables, to put new values in it. So let's go through some examples where the variables get changed and modified as the program progresses. After all, they're called variables because they vary. They change as the program executes. So we'll start with our int x position equals 60. We'll start the x position of our character at position 60 on the x-axis. The x-axis is the horizontal axis of the game, and this is just approximation. Our character that I'm displaying here is at position 60. Now, if this number changes, I expect the position of the character to change. So let's try that out. And remember, name, type, and value. X position is the name of our variable. The type is int, short for integer, a whole number without a decimal point, and the initial value here is 60. But it is a variable, so I expect to change it. So let's see what a line of code to change it does. I'm going to say x position equals x position plus 2. Now, in order to execute this command, we're first going to do the right side of this assignment operator. We're going to pull the value 60 from the x position variable and move it over and add 2 to it. So what this will end up executing is 60 plus 2. 60 plus 2 is 62. We assign the value that was calculated, 62, using this assignment operator to the variable x position. You'll see that that causes a new value to be stored in the variable. It just changed from 60 to 62. I don't know if you noticed it, but we moved our character. If the position in the variable changes, I expect the position of my character to change. And every time my x position changes, I expect my character to move along the x-axis. Once again, the x is the horizontal axis along here. Let's try it again. X position plus 5. At the time this code executes, x position now contains a 62. So that 62 will be retrieved. See the direction of the arrow? The 62 will be retrieved from the x position variable. 62 will then be added to 5 to calculate a 67. And that 67 will be assigned back into the x position variable. So after I calculate the 67, the assignment, or the equal operators, says store 67 back into the variable x position. And there's the 67 going back. Look at the direction of the arrow. The 67 gets stored back into the x position variable. Also, in case you weren't noticing it, our character moved. It started over here and moved a little bit for the first assignment operator and moved a little more for the second assignment operator. During any video game, it's going to be important to control the speed of the character. The character could be standing still, they could be walking, they could be jogging, they could be running. Hard-coded values like +2 and +5 tend to make it more difficult to vary the speed of the character. So what I'm going to do is set up another variable here named speed, and speed is going to control the amount of that the character moves. So if I put a high number in speed, the character will move far or fast. If I put a low number in the variable speed, the character will move slow. I'm going to set up this variable speed equal 3. The type of this variable is an integer. The name of this variable is speed, indicating it's going to control the speed of our character. And our initial value here is going to be 3. Now, instead of a hard-coded value like +2 or +5, I'm going to use a variable to control how fast the character moves. X position plus speed, I'm going to pull the value of both these variables. Notice where the arrow is between the variables. I'm going to grab the 67 in speed. That'll be my left operand. I'll grab the 3 from the speed variable. That'll be my right one. And when I add 67 plus 3, I'll get the value of 70. Now, this time, I want you to watch the position of the character. I want you to watch this character right here when I press the button. When I add and change the X position variable, that character is going to move. Now, watch the character right now. Bang, it just moved. The 67 plus 3 that I calculated, the 70, got assigned to the X position variable. The X position variable controls where this character is going to be, so it moved over when I changed the value of X position. That's what variables do. They change. And no more fundamental variable in a video game is the X and Y coordinates of a player. And what I'm showing you is how to adjust the position of that character and alter its speed. Now watch what I'm going to do. I'm going to change the variable of speed to -6. This is a negative number. When I want to move the character to the right, I want to add to the X position variable. But if I move the character to the left, I want to subtract from the X position variable. So what I'm going to do here is set the speed to -6. So now, not only can speed control the pace in which the character moves, but it can control the direction of the character. A negative number will move the character to the left. At the speed of -6, I'll go down and execute the next line of code. Once again, I'll pull the 70 out of X position. I'll pull the -6 out of speed, and those will be my left and right operand. 70 plus -6 is 64. I plan to change the X position variable, and when the X position variable goes down or is subtracted, I'm going to expect this character to move left instead of right. Watch the character as I press this button. Boom, the character just moved. When I assigned the new value of 64 to X position, this character adjusted its position on the screen to 64 and it moved back towards its original position. That's why it's important to use a variable to control how much you move the character. Not only can you change the speed in which the character moves, you can change the direction in which the character moves. In other words, this code, X position plus speed, is much higher quality than X position plus a hard-coded value like 5. Let's show you something new to do with variables. And this is going to be declaring a final or constant variable named startX. The type of this variable will be int. The variable name will be startX in all uppercase letters, and the value will be 10. But this time I'm going to put the keyword final in the front of it. And what the final says is this is the final value I will assign to the variable. With the initial value of 10 is the only value I will ever assign to this variable. A final variable is kind of an oxymoron. It's not going to change. I have this initial value of 10 in it, and what I'm going to do that is make that its starting X position. In a typical game, as you play a level, you're going to get killed and you want to restart it from the beginning. You're going to play a little more, you're going to get killed, you want to restart. I'm going to set up this final variable as my initial starting position, and every time I get killed, I will reset the X position variable to 10. Now again, what I want you to focus on here is the position of my player. With the current value of X position 64, the player is at about 64 paces in from the left of the screen. This is position 64 on the X axis. Watch while I press the button. Bang! I change the X position to my default value of 10. Every time X position equals start X, I will reset the player to position 10 on the X axis. That's why my character moved way over to the left of the screen. And you're going to want to set up some sort of constant variable like this in order to make sure that your player starts at the same position every time. This initial value of 60, with a hard-coded value, you're going to have to reset it to 60 every time. You set up a final variable like this, just reset it to there, and bang, you're on your way. Every time the character dies, it resets to the same position, start X. There you have it. That's a little screen showing you how to change variables. Let's move on and look at the variable types double and char. A double variable is a numeric variable that can hold a decimal point. Again, I like to use money. Everybody understands it takes a decimal point to store numbers. This is $50.49. Let's look at what we can do with the double variable. Some of the things you might see on your screen is how much money the current player has. That's fairly common. Every time you play a video game, there are certain values that it shows you on the screen. What is your current score is usually on the screen. Maybe your health value, so you know when it's getting low, is on the screen. And if it's a game where the player collects money and spends money, it's nice to show the current balance or the current money that the player has acquired. This is sort of the information bar along the bottom of the screen or one side of the screen that tells the player what is their current value of the money they have and what is their current ranking. We'll get to ranking shortly. I'm going to assign an initial value of $50.49 to the player's money variable. You can see it gets stored over here in the money variable. I'm not only declaring the money variable, that's what double does in front of it, but I'm also giving it an initial value. Now the next line of code is going to change the money variable. Now notice you only declare the variable once. Once you've declared the variable money, you don't keep putting double in front of money. You declare the variable once, fulfill your requirement to declare the variable before you start using it, and then you just use it as the program progresses. I'm going to subtract a certain amount, $12.34, from my current money. You'll see that I pull the value 5049 from the variable money, and I'll subtract from 5049 the 1234. Notice the direction of the arrow. I pull the current value of money out of the variable, I do my subtraction, and then, bingo, bango, bongo, I update the value of money with the new amount. 50.49 minus 1234 is the value 3815. And you can see the assignment operator, this equal sign, will take that value 3815 and store it in the variable money. Also notice how money is reflected on the screen. Just like with X position, the variable money is going to track the value I display on the screen for the player. Money went down, so I want to show the user their updated bank account. The viewer cannot see what's in computer memory. I have to write some code that takes that value and displays it on the screen. We'll do that later, but for now, notice how when I change the value of money, I update the screen to reflect the new balance. Once again, you can subtract a constant value there, but as we know, everything costs a different amount. Expensive items cost more, inexpensive items cost less. So what I'm going to do is set up another variable here. I'm going to set up a variable cost. Cost is how much a particular item costs. Since it's money, it's going to need a double variable, a decimal point. I'm going to set up a variable cost with initial value of $7.11. So once again, the type of this variable is double. The name of this variable is cost. And the current value of this variable is 711 or $7.11. It's much better to use a variable to change my variable money. Now, when I subtract from money, I will subtract from the variable cost. So this variable can be different depending on what I'm buying. With the current value of cost, I will take the value money, 38.15. I will extract the value cost from memory, and I will do the equation 38.15 minus 711. And I will calculate the new money balance of our player. Turns out that's 31.49. 31.49, because of this equal assignment and will be assigned to the variable money. Notice the direction of arrow. That's what the assignment does. The assignment says I want to put a new value in my variable money. 31.14 is the new amount that we have. 31.14 is the value I will display to the player on the screen to show them that their bankroll is going down. If you keep buying things, the amount of money you have. Alternatively, when the player encounters some piece of gold or some cash lying on and they pick up that money, we can adjust the size of money to reflect that it's going up. I don't show that here, but obviously if money can go down, hopefully money can go up. I mentioned player ranking earlier. A ranking of A indicates this is a strong, powerful top-line player. A ranking of C indicates that this is a medium player, not a lot of power or not a lot of money at this point. And of course, a ranking of F would be bad. That would be a player that is not doing well. Rank is going to be represented by our well-known scale of A, B, C, D, and F, where A is good and F is bad. There's something interesting about characters. I'm storing a single character here. The type is char or character. The name of the variable is rank. How strong is this player? And the current value or initial value is C. Now, it turns out we can do a little math on character variables. I'm going to do a rank minus 1. I'm going to pull the value C out of the variable and subtract 1 from the value C. Turns out that's good. If I subtract 1 from the value C, the rank changes to B. So I assign the new value B to the variable rank. You can see it reflected there. I also update the player's rank on the screen to show that their ranking has changed. This player must have acquired more power. This player must have acquired more strength. I'm going to raise their ranking within the game to show that they're getting more powerful. It's kind of interesting. You wouldn't expect it, but you can add and subtract from character variables just like you can add and subtract from integer variables. Let's do it again, but let's use a new special way to change a variable. This is called the minus minus or decrement operator. Turns out we add 1 and subtract 1 from a variable quite often. And the minus minus or decrement operator subtracts 1 from the variable rank. Notice how the rank changed from B to A. When you take B and subtract 1, you get A. So that's what this is. Also notice that there's arrows on both sides. This is sort of a shortcut command. And what it does is it pulls the current value of the variable rank, which was B, subtracts 1 from that, makes it an A, and stores the result back in the variable rank. Minus minus is called the decrement operator, and it subtracts 1 from the rank variable. Plus plus is called the increment operator. Plus plus is a shorthand operator, and what it does is it adds 1 to the variable rank. If the player's ranking can go up from B to A, it could also go down from A to B. If the player loses strength or loses power, we want the variable rank to go down. So I'll add 1 to rank. The variable a just changed to a b. A plus 1 is defined as b. Does that make sense? Think about it. A plus 1 should advance to the next letter in the alphabet. A plus 1 is b, and that's what the plus plus does. Plus plus and minus minus also, of course, work for integer variables. If I've declared an integer variable score and I want the score to go up by 1, I could just type in score plus plus semicolon and it will add 1 to the variable score. That's just some of the ways we can change variables. We can modify it. Again, hard-coded values, yes, you can change your variables that way, but it's better to use another variable to modify our variable so we can alter the cost, we can change the cost. Let's do some math on our variables. Let's change the variables using math equations. Now, a very common thing to do in a video game is to track the elapsed time for a game level. Almost all, well, not all, but many video games will tell you how long it takes to do a level. You start out at 0 seconds and you add seconds and display to the user how long it's taken to get through a particular level. So in order to do this, I'm going to declare me some variables. I'm going to declare an integer variable named minutes and another one called seconds. That will be the elapsed minute and seconds it takes to complete the level. I'm going to create a third variable called time, and what time is going to do is be the overall number of seconds. There's many ways we can keep track of time in a computer program and therefore keep track of time that it takes to do a level in our video game. And one of the easiest ways to do it is just keep track of time as raw number of seconds. So what I'm going to do is set up my time variable, and we're well into the game here, and 125 seconds have elapsed since the start of the game. So at this point, time is set to 125 or 125 seconds. Now the user doesn't want to see 125 seconds on the screen. The user wants to see the number of minutes and seconds that have elapsed since they've started this level of the game. So what I'm going to have to do, if this is the raw number of seconds, I'm going to have to do some calculations. I'm going to have to do some math to calculate for the user the time in minutes and seconds. Now to show you how it's done, to calculate the total number of minutes given time in raw number of seconds, I'm going to take my time variable and divide it by 60. Critical thing here is to understand that this is going to be what we call integer division. In the Java programming language, when you take an integer and divide it by another integer, the result will be an integer. So what it's going to do is ignore any remainder or leftover part. I showed you the actual equation happening over here. If I take 60 and divide it into 125, we should know that 60 fits into 125 twice. And that's what integer division is going to get you. Integer division will not have a decimal point. Integer division will tell you that 60 divides into 125 twice. So when I divide 60 into 125, the answer is 2, and 2 is going to be assigned to the variable minutes. Do you see that? There is going to be a remainder here, but integer division ignores the fractional or the remainder after this division. This equation calculates 60 divides into 125 twice. A 2 gets assigned to the variable minutes, and you can see by the direction of arrows the minutes variable now contains the value 2. It should be pretty clear. There's 2 minutes in 125 seconds. Now, how do I calculate the seconds? In order to calculate the seconds, there is a built-in operator to the Java language using the percent sign, and it's known as the remainder, or more technically the modulus operator. And what the modulus operator does is calculate the remainder after doing integer arithmetic. What I'm doing here is basically time divided by 60. When you do time divided by 60, it has a remainder of 5, right? 60 fits into 125 twice. 60 times 2 is 120. So by the rules of division, I subtract 120 from 125, and I get a remainder of 5. This remainder is the number of seconds left over if you take out the 2 minutes in 125. By calculating the remainder, time modulus 60, I'm able to calculate that there are 5 seconds left over after taking 2 minutes out of 125 seconds. And that's the number of seconds I want to display. So I've taken that remainder 5 and stored it in the variable seconds. This equal assignment operator, look at the direction of the arrow, will store a 5 in the variable seconds. If I were displaying to the user the elapsed time of the level on the screen, I would take the contents of the variable minutes and display it with the label time. I'll take the contents of the variable seconds, do a little magic here and display that as 05, and show the player that the elapsed time that they've currently taken to accomplish this level is 2 minutes and 5 seconds. As the game progresses, expect this time variable to increase. For every second it takes, let's go to 126, 127, 128. But when I'm ready to display the time, I'll run through these calculations again, calculate the new value for minute, calculate the new value for second, and update the screen. And what I'm trying to do here is to kind of explain how integer arithmetic works. I've done another example down here just to hopefully make it clear. The way Java and many programming languages work is if the two operands during a division are integers, then the result will always be an integer. Notice how I've declared an integer test to be equal to 1 divided by 2. Well, technically, 1 divided by 2 using integer arithmetic is the value 0. 2 does not fit into 1. 2 fits into 0 one times. So I want it to be clear here. When you divide two integers, you get an integer result. 1 divided by 2 is 0. If you want a decimal point, if you want 1 divided by 2 to be 0.5, you're going to have to make one of the operands a double or floating point number. Notice how I changed the equation. It's no longer 1 divided by 2, it's 1 divided by 2.0. If one or both of these operands is a double value, then the result will be double. 1 divided by 2.0 is 0.5. If I want the decimal point, one of the operands has to have a decimal point. Notice how I declare this variable to be of type double. If I use a double on this side of the equation, I will have a double result. Notice how both of these are integers. I'm going to get an integer result of the division. Notice how one of these is double. I will get a double result. Technically, both of these are double. What Java and other programming languages will do is they will automatically convert that to 1.0. And 1.0 divided by 2.0, again, is 0.5. I wanted to show you a little math. I wanted to show you the types of math we do in video games. Calculate the elapsed time in minutes and seconds that the player has spent on a level. And I want to be very clear. When you divide two integers, you get an integer result. When you divide doubles, you get a double result with a decimal point. Next, let's look at a new type of variable. A very, very, very different type of variable than int or double or char. Let's look at a string variable, and more specifically a string object. Because in Java, strings are stored as objects, not like regular variable. So I'm going to declare a string variable name. A string is multiple letters. A single char is a single letter. But a string is a string or multiple letters. Now when I declare the variable string, notice how I did not assign it initial value. So it's basically going to create an empty object variable. Name at this point has no value. It's not until I assign something to that variable name that I will store something in the variable. Whoa, what happened there? Look how much bigger this is than a normal variable. That's because it's an object. Java is an object-oriented programming language, and many things in Java are stored as objects. A simple int or char is not an object. But when you get to a string, the string's a little more complicated. The string takes more memory. The string takes an object. Whenever I assign a value to a string variable, Java will automatically create an object to hold that string. So I'm going to assign the letters Mario, M-A-R-I-O, to the variable name. Java will build an object and assign that object to my name variable. Curious. Turns out name is not the object. Name is the variable that references the object. See that line? Name is what's called an object reference. It allows us to access the object in computer memory. And keep in mind that object takes up memory, and we'll see why in a minute. I can use an object variable much like I can use any other variable. What I'm going to do is access the variable name, or the letters Mario, and bring it in as the left operand of this concatenation operator. That looks like numeric plus, but it's not. It's called string concatenation. What I'm going to do is take the letters Mario and append or concatenate it the word brothers. So when I put Mario and brothers and concatenate them together, I get a bigger string, Mario brothers. So I took the Mario out of the string variable, added brothers to it, assigned it back to name. Look at the direction of this arrow. I'm assigning Mario brothers to the name variable now. It's quite a different operation. This is called string concatenation. When I add two strings together, I get a bigger, larger string. Interestingly enough, I can also add numbers to it, but it's not going to add the number 2 like math does. Since this first operand is a string, it's going to do string concatenate. It's going to concatenate the letter 2. It's going to convert this number 2 to a letter and add it to the variable name. Currently in the string object, we have the text Mario Brothers. So Mario Brothers will be the left operand, and I will concatenate a 2 onto Mario Brothers. And you'll see, because of the assignment operator to the variable name, that we have now changed the contents of the name variable to Mario Brothers 2. I know it's confusing that the plus, when used with strings, does concatenation. It takes a short string and makes it a larger string. But when you think about it, concatenating or putting two strings together, the plus operator makes sense. You just have to be careful. Remember how I warned you that it's important to understand the name, type, and value of each variable? When the variables on the either side of the plus are integers, it will do numeric addition. 3 plus 2 will be 5. But when the operand on the left-hand side, name, is a string, it will do string concatenation. So Mario Brothers will get the text letter 2 appended or concatenated to it, and Mario Brothers plus 2 produces Mario Brothers 2. You'll get used to it once you see it a couple of times. One of the great things about strings being an object is we get access to something called methods. Length is a method of the string class. The length method will literally count how many letters are being stored in the string. Well, Mario has 5 letters. Brothers has 8 letters. 5 plus 8 is 13. The letter 2 is the 14th letter. So the length method will count how many letters is stored currently in the string variable. And if you look carefully, there's 14 letters. Notice this line has an arrow on each side because dot length will say go into the name variable, access the length, count the number of letters, and then return back the value 14 because there are 14 letters. And that value 14 that length returns is going to be assigned to the variable len. So len, short for length, will be assigned the value 14. The 14 letters that length returns gets assigned to len. Len gets stored as 14 in the variable length. Methods are great. Methods allow our objects to do things. So this method length is letting our object tell the user, tell the program how many characters are currently being stored. If I had called length immediately after this, it would have returned 5 because there were 5 letters in name at that point. But down here, there are 14 letters, Mario Brothers 2, so it returns a 14. There's other methods too. A handy dandy one is to uppercase, which will convert my string to uppercase letters. When this line of code executes, I want it to convert to uppercase letters. So I'm going to click here and notice how when name to uppercase converted everything to uppercase, I reassigned it back to the variable name and my data updated to Mario Brothers 2 in all uppercase letters. That's what toUppercase does, is it returns a string with uppercase letters in it. Before I leave this slide, I do want to point out once again, when it comes to using variables, Java is a strongly typed computer language. I am required to declare a variable before I use it. In this case, I'm declaring it to be a type of string so I can store letters in this variable. The type of the variable is string. The name of the variable is name. The value after I assign something to it will be Mario in this case, and Mario Brothers in uppercase after all of this code executes. Notice how I only have to declare the variable once. I declare string name here, and then I use it. Every time I use name, I repeat, I do not keep declaring name over and over. If I put the word string in front of this, I'd get a nasty error message saying you've already declared it. Remember, you only declare the variable once. That's a string object. As we get deeper and deeper into this course, we'll look at many other types of objects. There is one more object I want to discuss right now. It's called the scanner object. The scanner object is useful for getting input from the keyboard. If you need to get some information from the player of the game, you might need to go out to the keyboard and ask the user a question and get some input. So let's look how the scanner object works. I'm introducing objects fairly early in this class because you're going to see them in the code that you look at. So I want you to get a basic understanding of objects at this point. We are not going to be experts in objects after this lesson. We're just going to be introduced to objects in this lesson. As the course progresses, we'll go into more and more details about objects because they are certainly very important to both video game programming and object-oriented programming. Let's start out. The way we use a scanner object is we do an import command at the top of our code. At the top of our Java program, we're going to do an import of java.util.scanner. Scanner is what's known as a class, and a class is used to build an object. So what we're doing here is we're adding the scanner class to our program. Another way to think about the difference between a class and an object is to compare it to a blueprint to a house. A class is to an object like a blueprint is to a house. A blueprint is a set of instructions on how to build a house. Well, that's pretty much what a class is. The class is the blueprint or definition for creating an object. And step one in using the scanner class to build a scanner object is to import that scanner class, add it to our program. So put that line up near the top of your code. Somewhere in the execution of your program, when you're ready to do keyboard input, you're going to have to build a scanner object. And in this case, input is the scanner object. You'll also notice this is a variable declaration. There's the type of the variable, scanner. There is the name of the variable, input. And there is the thing that I'm assigning to it, a new scanner object. Once again, you can see that objects take up space. Objects take up memory. Input is the reference variable that I'm going to use to access this scanner object. The reference variable input and the object itself are two separate pieces of computer memory. We've just built our scanner object. Let's see how to use it. First, I'm going to do a little output. I'm going to do system.out.print enter and int. Now notice the arrow. To my output, the words enter and int were put. Whatever's in these double quotes here is going to be sent to the output of the screen. I can't ask the user to put something in without telling them what I want. So I'm asking user to enter an int, a number without a decimal point. System in this case is a class. Notice how system has a big S. Notice how scanner has a big S. Scanner is a class. System is a class. Now I'm going to use the system class to access what's called the out object or the output object. Notice how input is an object variable. Out is also an object variable. I'm then going to use it to access what's called the print method. I want to print some text to the screen. I pass what I want to print to the screen, enter an int, and you can see it very kindly outputs that to the screen. Now I can do my input. I'm going to use my input object to access the next int method. One of the great things about objects is they have these things called methods. An important method of the scanner object input is the next int method. Give me the next integer that the user types in on the keyboard. Now notice down here in the output, see that 27 there? That's the 27 that the user types at their keyboard. I asked them to enter an int and they kindly typed in 2, 7 and the enter key. That 27 gets transferred to the scanner class and that data 27 is being stored in my input object. And what the next int method does is it takes that data 27 when I call it and returns it to the caller. So input.nextInt, see that arrow right there, is going to return the 27 that the user input. So the 27 comes back from the input object and gets assigned to the variable score. So I'm asking the user to alter the score. So score is assigned to 27. I put a 27 in the variable score. Notice the direction of the arrow. The equal or assignment operator says take this value that input.next returns, assign it to the variable score, and you can see it gets written to memory here. Now I'm going to sort of echo back to the user what they input. Again, system.out print. In this case, I'll do a println, which is short for print line. Print a line of output. This will cause it to output an entire line to the console or output. And what do I want to output? I want to output the words input colon. I want to append it the score. So I'm going to extract the 27 from the variable score and then send that 27 to the output. See the arrow? I'm extracting from the variable score here and then sending that 27 to the output. And you can see on the output input 27 showed up. Input colon 27. There's the input colon that I asked it to output. There's the 27. This println will cause it to print to its own line. Next up, I'll do another system.out print. So I'm sending something to the screen or to the console or to the output. Notice again, I'm using print this time. I'm using print so it doesn't end the line. It stays right there. I ask it to output the message enter a double, and you can see enter a double showed up on my output. It also did not terminate this line. So when the user types in some input, like 499, the user types this 499. This is what the user types in. I asked them to enter a double number with a decimal point. They kindly typed in 499. That 499 got transferred to my input object, my scanner object input. Scanner is holding that 499. The method next double in this case, see this syntax? I'm going to the input object. The dot says go inside that input object and access the next double method. The next double method will go up and look at what the user typed in, the 499. The 499 that the user typed in will then be transferred back to the input.nextDouble. Notice the arrows on both sides. The first arrow over here is go inside the object and run next double. Next double will grab that 499, send it back to the user, and that 499 that comes back to the user, back to the program, will be assigned to the money variable. And once again, that assignment operator will take the 499 that was returned by next double and assign it or put it in the money variable 499. Finally, we'll simply echo out what the user input. This line is sort of a confirmation to the user that their input was received. I'll output the word input colon. You see it right there. I will then go to the variable money, take the value 499 out of the variable money, and then transfer it to the screen. And there it is. 499 shows up on the screen. This is a very simple program that asks the user to enter two numbers and echoes those two numbers back out to the screen for the user. Remember, the first 27 is what the user typed in, and this is me echoing it back out. The first 499 is the user's typing in on the keyboard, and the second one is it being echoed back out to the user to confirm that their input was received. Well, I hope you enjoyed that lesson. Once again, I'm Professor Chris Ferguson. Please visit us at gamesci.com to see more interesting lessons, courses, programming exercises, quizzes, all the fun stuff.